Good morning, students. So, today we're going to talk about crystallization. It is a separation technique as well as it is a purification process. So, in this process, we're going to see about how to pure copper sulfate from impure copper sulfate. Let's see the procedure. Take some impure sample of copper sulfate in china dish. So, this is a china dish. So first of all we're going to take some impure amount of copper sulfate in it. Dissolve it in minimum amount of water. So we're going to take some water and dissolve it. Now what we will do? Filter it out. Now we're going to filter the filter the solution of copper sulfate. So the impurities which are insoluble will left behind and will get a filtrate. In this filtrate, we will have copper sulfate solution and the insoluble impurity will left behind over here. Now we're going to take this filtrate which have copper sulfate solution again in china dish, and we're going to evaporate the water from copper sulfate solution to get saturated solution. What is saturated solution? It is having maximum amount of copper sulfate. The extra amount of water would be evaporated, and also the crystallization occur in saturated solution only. That's why we're going to evaporate the excess amount of water so to get saturated solution. Now what we'll do, we're going to keep for evaporation, then we'll cover it with filter paper and left it undisturbed. You will keep for a day and undisturbed. Will not touch it, will not disturb it. What you will see? We will see the blue crystals are produced. Copper sulfate is having blue crystal. So this was about the crystallization process. So dear students, in this technique we are not only separating out, or we are separating the impurities from the copper sulfate, but also we are purifying. Why? Because crystallization, or crystal, is a pure form of substance. The crystals are arranged by regular arrangement of atoms. So when there is a crystal formation, there are only those atoms which are of the crystals which are joined together and forming crystal. No other impurities are there in the crystal. So this is a separation technique as well as a purification process, and it is better than evaporation. Now let's see how can we obtain different gases from air, or separation of different gases from air. So this is the setup. Look over here. From this will pass the filter air. There is a filter, so air will filter out and will go inside this compartment, and you will see here in this compartment the air would be pressurized. It will be compressed, and the normal air, warm air, will pass in this chamber, and in this chamber we're going to pass freezing cold water so to cool the air. But let us understand what happens when we are pressurizing and lowering the temperature. Let's see. So dear students, in a gas the molecules are far apart, but when it is applied pressure, the particles come closer. So for example, in a gas, when we are applying pressure, the particle will come closer. So actually we are making it liquid. So if you are applying pressure to a gas, it will become liquid because the molecules will come closer. So that's why we are pressurizing the air in the process. And why we are lowering the temperature? For example, gas have more vibration energy, they have more temperature, so more kinetic energy. In gas, there is particles are in motion. They are having more kinetic energy and more vibration energy. So if we lower the temperature, the kinetic energy will be less less vibration. So we are actually making them liquid. In liquid phase, what happened? Their molecules are having less vibration energy compared to the gas, less kinetic energy compared to the gas. So that's why by lowering this temperature, we are actually converting or reinforcing. We are reinforcing the process into liquid. So we can say gas at high pressure and low temperature is turning into liquid. So gas on frequency on high pressure, the gas turns to liquid. So this air which was in gaseous condition on application of high pressure and lower temperature turns to liquid air. Now let's see the process again. So this is the setup. So students, you understood why we are pressurizing the gas, because we want to convert into liquid. Now this normal air is passed in this chamber and freezing cool water is passed, so the air get cool. Now this cold compressed air is passed in this chamber. Now what happened? We know that carbon dioxide at high pressure and low temperature becomes dry ice. So this carbon dioxide will separate out from this area, and the liquid air will go in this chamber, which is known as expansion jet. Now what happened? We are going to use fractional distillation column, or there is an application of fractional distillation over here. What was there in fractional distillation column? Different amount of, we can say, different miscible air or different miscible gases or liquid components were separated at which were having boiling point less than 25 degree or 25 Kelvin. For example, look over here. Oxygen boiling point is -83, argon is having -186, nitrogen is having -196. So these are the three major components of gas: nitrogen, oxygen and argon. 20.9% is oxygen, 0.9% is argon, 78% is nitrogen. So these are the three main components of air. And you can see the difference in the boiling point. It is less than 25 Kelvin. So we are going to use the process known as fractional distillation. Let's see. Now what happened? As the air is liquid, which is containing nitrogen, argon gas and oxygen gas. Now let's see the boiling point. 183, 186, -196, -183, -186, -196. So dear students, you just understand, if the air is liquid at -200 degree centigrade, -200 degree centigrade, so -200 on increasing, we are increasing temperature. Understand, -200 is less. We are moving towards this, or we can say this line. First will be -196. At -196, the liquid nitrogen will turn to nitrogen gas, but these two gases will remain in gaseous state. So on warming the air, so here when air is liquid air on expansion, what is expansion? Lowering the pressure and increasing the temperature. So moving from -200 to -196, nitrogen gas will be in gaseous state, but these two gases are still in the liquid state, we can say. And again on, we can say, lowering the temperature or increasing the temperature. So -186, argon gas will be comes out in a gaseous state, but at -186, both nitrogen and argon gas will come out in a gaseous state, because the boiling point of nitrogen is -196 and that of argon is -186. So both these gases will come out at -186, but the liquid oxygen will be in the liquid state. The oxygen will be in liquid state at -183. At -183, oxygen will be in gaseous state, but the temperature is -186. So at -186, these two gases are in gaseous state, but the oxygen is in liquid state. So in this way, the liquid oxygen is separated from the gaseous component. So in fractional distillation can be used if two or more miscible liquid or gas having boiling point difference less than 25 Kelvin. So this was about the separation of components.